Welcome to Constellations, the podcast from Kratos, where industry leaders share their thoughts and experience on the future of space business, policy, and opportunity. If you like Constellations, please support us by giving a rating and review on iTunes. And don't forget to share this podcast online to help our community grow.
Welcome to Constellations, the podcast from Kratos. My name is John Gilroy, and I'll be your moderator. Today, we welcome Shawn Williams, Vice President of Government Affairs and Strategy at Pacific Dataport. During today's podcast, we will discuss the process of delivering broadband to remote areas around the globe, specifically rural Alaska. Not just the challenges like reliability, integration, and testing dynamic technologies, but how one group is actually overcoming those challenges today to deliver services and how the Aurora network will benefit Alaskan communities. To walk us through the process of building this new network, we have invited Shawn Williams, Vice President of Government Affairs and Strategy for Pacific Dataport. Pacific Dataport is a new company building an innovative network to serve Alaskans with reliable, affordable broadband access. Okay, Shawn, you're up to bat here. So what is the mission of the Aurora Network project, and how did it come to be?
Hi, John. Thank you for having me. Probably what I would start out with is just sharing that MicroGEO, our sister company, has been providing satellite broadband and TV to Alaskans, especially rural Alaskans, for almost 40 years. MicroGEO has tens of thousands of customers. And as a reseller, MicroGEO owners started to realize that satellite owners were running out of capacity when it came to serving satellite broadband here in Alaska. The bottom line became that at that time, no one was interested in serving Alaska's, problem of connectivity. So in 2017, the owners of MicroGEO started Pacific Dataport. And Pacific Dataport's first project is the Aurora project, and that consists of two satellites. The first one being our soon-to-be launched Aurora 4A MicroGEO.
The other one is the bigger one, the ultra-high one?
Yeah. The second one will be a Boeing FlexSat, and that one will have over 100 gigabits per second.
Well, this sounds like the classic business solution problem, and problem solution for a business company. So the problem is running out of capacity. And so were there other efforts? Were there maybe other companies that tried to solve this problem and they couldn't do it effectively or at a low cost?
Well, doing anything in Alaska is expensive. I mean, if you're doing terrestrial, fiber, or microwave, you're basically going to spend, easily $125,000 plus per mile. And, you're talking about hundreds of miles of fiber over tundra and around mountains and the streams and the rivers that we have up here. Almost everything is naturally a barrier. And when you go into the realm of satellite, you remove all of those problems, especially when it comes to EIS and, environmental impact studies. And, it makes things a lot easier when you're dropping a user terminal in the community and just connecting.
I got up early this morning, did research on you and your company, and I went to your website, and I learned a new word called a digital desert. And so I guess this is a phrase that happens in rural areas of Alaska. And then what happens with digital deserts or communication deserts or something like that, you wind up with unserved or underserved communities. And so what do these two words mean, and what does it mean for Alaska?
That's a great question. Since 2015, the FCC has defined unserved as, quote, households or businesses that lack access to wireline broadband service at speeds that meet the FCC threshold of 25 down and 3 up. Since the big infrastructure bill and the NTIA's new responsibilities, the new definition of unserved is, quote, where less than 80% of the population has no access to broadband at all or no access to reliable broadband, which it defines as speeds of less than 25 by 3 upload and latency sufficient to support real-time interactive applications. Underserved is now defined as areas where at least 80% of the population has access to speeds under 100 by 20 and sufficient latency. So, when you start thinking about unserved areas in Alaska, I'll kind of give you an update of what that looks like right now. 36.3% of rural Alaskans still have no wired broadband connection of 25 by 3 or greater. No rural Alaska school meets the FCC's educational goals of 1 megabit per second per student. In Anchorage, a lot of competition, a lot of fiber. In fact, interestingly enough, in my neighborhood, about 2 weeks ago, they started running fiber to the home. One of the providers did. And that is a very new development. And boy, am I lucky to have that in my neighborhood. But in Anchorage, we're paying about 24 cents per gigabyte of data. In Adak, which is at the end of the Aleutian chain at the far west side of Alaska, they're paying $22.22 for that gigabyte. You know, digital redlining is a problem. So even where there's fiber and it runs down the middle of the road, residents are often bypassed as potential customers for one reason or another. Off the northern coast of Alaska, 25 by 3 fiber broadband is offered. It just started probably in the last 12 months, but that costs $499 a month. It does have a 150 gigabyte per month limit. And often, you know, people meet that limit and they go to buy more and the provider literally says, thanks, but no thanks. We're not going to sell you more. So that's a possibility. We also know that rural Alaska schools and health clinics often pay $40,000 to $60,000 per month for 25 by 3 service. And that is at each school or health clinic. And then finally, a stat that I like to share is that approximately 240 rural Alaska villages are still considered unserved or underserved. And those statistics are current and factual.
You know, Shawn, if I would just strip out all the information about Alaska and gave those statistics, you would think that's rural Ethiopia, or someplace, you know, in Siberia or something. But this is part of the United States. It seems like that's increasingly we're starting to think of broadband as almost like a utility, aren't we? I mean, I think back of LBJ in rural Texas and electrification, and that was considered to be. Now this is the new utility, but this is really part and parcel of just living, isn't it?
Yeah. It's funny that you mention broadband as a basic utility. Just recently, I listened to an interview that one of our most amazing clients, Chief Mike Williams from the Akiak Native community. It's a very remote community of about 400 residents and about 100 homes. And he literally equated broadband coming to his village, which we helped them bring, as, you know, he remembers when electricity came to the village. And for him, this is like when electricity came to the village. It opened up a ton of new opportunities, everything from telehealth to better education. If someone wants to go to college or earn a vocational degree, those are the kind of things that become possible.
And, you know, if you just put in the big picture, the last 5 years, I've interviewed people at the VA, and what they've said is that COVID's forced them to increase being able to connect to hospitals and clinics in rural areas where a lot of veterans live. And finally, they can get the services that they put their lives on the line for. And I think we can provide that by opening up to more rural areas in Alaska. This whole medical thing is it's very important. It's just transformed with COVID, hasn't it? Yeah,
well, COVID definitely made broadband, it put it on the front line as, you know, kind of pushed it into that basic utility category. I'll also mention that Alaska has the highest per capita of veterans per capita, you know, more than any other state in the nation. And as you mentioned, you know, it's really important as far as making sure they have good health care.
Okay. So quick summary here. Some of the reasons behind inadequate broadband all throughout Alaska is geography. It's basically what it is. And what you're positing is that with this new system, you're positing the Aurora network broadband, it'll solve a lot of those problems. And it sounds like it'll reduce cost as well.
Oh, absolutely. What we know is that subsidized fiber off the northwest coast of Alaska results in really expensive and slow broadband. And the economics of it are pretty simple when you think about the fact that the providers get top dollar for the capacity they're providing to the schools and health clinics. We believe that creates a price floor, and it keeps the prices really high for that capacity. And it's so high that the providers ultimately decide not to go outside of those customers. You know, otherwise they'd have to lower their prices.
You know, Shawn, thousands of people from all over the world have listened to this podcast. Go to Google and type in Constellations Podcast to get to our show notes page. Here, You can get transcripts for all 100 plus interviews. Also, you can sign up for free email notifications for future episodes. So we have a pretty good solution in the offing here. And so what I want to do is maybe review the steps by this. If you look at connecting communities, it's a long journey. And like all journeys, begins with the first step. So in the case of building a satellite broadband network for Alaska, obtaining the right orbital slots is usually that first step. So what was that process like for you, getting that slot over Alaska?
Well, because we have two satellites that are part of the Aurora network, what we knew right away is that we needed to secure those two orbital slots. And we also knew that directly south of Alaska would be best, not only because it's easy to find, but also because, there's no kind of weird direction. And we ended up procuring two slots at 163 degrees and 154 degrees west. Because it's not a high demand area, we were able to get those and fairly easily and quickly. That might have been the easiest step out of all of this.
I'm going to ask the awkward question because I'm in the Washington, D.C. area. It's obvious there are military bases in Alaska. I would assume that the military has special communications satellites that are flying overhead as well. I don't know if we're allowed to ask that question or not, but they probably do, don't they?
Well, I would suspect that they do. And as with any good business plan, it is our intent to pursue those opportunities.
Yeah. Okay, so we've got the slots picked out. We've got two satellites looking at. Now, at the other end of the spectrum, for an ideally positioned satellite, there also must be an ideally located ground system. So what about the other end on the ground here? So can you walk us through the process of selecting a greenfield site for your ground system?
The LBI SAT location in Eagle Mountain, Utah was perfect. They have almost 100% clear sky days, and the atmospheric weather conditions are near perfect at that location. We also have access to low-cost, redundant fiber-based internet services with multiple providers. Kind of the good news, I believe Google has a location there, Facebook, Amazon. I mean, everyone's in that valley, and if you can pretty much assume that they're all there for a reason. And one of those reasons is that there are plenty of options and competition when it comes to fiber in and out of the area. So power reliability was a really big deal, and clear look angles with no chance of future blockage by future construction. The LBI SAT's location is nice and big and secure. I mean, nothing is going to be built right next to it. So we feel comfortable with that. We also looked at LBI SAT's experience as being an owner operator of the facility. And then it comes right down to the economics of it, right? What are we paying for access to the fiber? What are we paying to be at that facility? And everything works out really well. Our goal is to make sure that we do this the most economical way possible, because that directly translates to lower prices for our customers and lower prices ultimately to the consumer.
Well, Shawn, we talked about the satellites. We talked a little about, the ground systems. Let's focus more on the antennas. So what are the features of the antenna system you installed, and how do they support the mission for increased reliability?
Well, probably the best thing about the antenna and all of the components, they have a long operating history. That was really important to our engineering team. Redundancy for all critical systems to include tracking. The sub-reflector tracking adds a Z-axis component, which is able to further improve performance over traditional pedestal tracking by refocusing the antenna, caused by thermal contraction and expansion. The fact of the matter is that the Kratos and ASC team have a long history of engineering excellence and support for their customers, and all of that was really important to our team here in Alaska.
Okay, let's bounce back up to the satellites. What I've read is that Pacific Dataport decided to commission a MicroGEO satellite to pair up with this antenna system we just talked about. So this is new world for me. So what is the difference between a MicroGEO and a typical GEO satellite? I guess maybe there's technical difference or size, I guess, huh?
Well, I've seen this satellite and it is awesome. It is pretty amazing. Our satellite, which was built by Astronis in San Francisco, is about 7.5 gigabits per second. It is literally the size of a commercial dishwasher. It fits into kind of a plastic composite box. They've got it kind of locked down in there, and they'll transport that to Cape Canaveral, and it'll go up on a SpaceX Falcon Heavy fourth quarter. So we're pretty excited about that. The size of the satellite just being smaller translates to, of course, less weight and ultimately less cost to launch. And, we're excited about getting that up in the air and, start providing service to our customers.
Well, I tell you, I'm going to have to add it to my vocabulary notebook. You got nanosatellites, microsatellites, mini satellites, CubeSats, you got geo, and then we got MicroGEO. So this is going to be a whole new world, another size to worry about. But I have read that it reduces costs drastically for providing that service. And that fits in line with your most economical model, doesn't it?
Yeah. The way we planned this is that our first satellite would be more affordable. And then our second bigger satellite, which is going to, of course, cost more. But this first one made it possible to kind of start out with a slightly more affordable first step when it comes to our Aurora network. It also allowed us to generate a revenue flow, which is always more attractive, as we look for investors and partners. So yeah, it was a logical first step for us to go ahead and have a smaller, more affordable satellite, and then we get the big one. And we're actually fundraising for the bigger one right now.
Shawn, I've seen a lot of projects, especially greenfield projects. And anytime an organization, no matter where it's at, Alaska or Alabama, anytime an organization decides to build a network to connect a community in a way it hasn't done before, the process of integration and testing is difficult, maybe even challenging. So can you describe that process?
Well, what I can share about that is that the MicroGEO still uses traditional ground station equipment, and the process to commercialization of a GEO is normal, right? Post-launch, we'll go through the alpha and beta testing, and hopefully in a month or two, we'll be up and ready for commercial service. We expect the process to go very fluidly.
Well, I got to ask the direct question here. I'll ask a citizen of Alaska question, So once the Aurora Network project is complete, so what are the resulting benefits you expect to provide for Alaskan communities?
Our ultimate goal is to sell cellular and broadband backhaul capacity to tribes, tribal consortiums, schools, health clinics, and Alaska Telecoms. Our wholesale pricing will be a fraction of what everyone's paying right now. In fact, it will bring Alaska very close to the wholesale pricing that you see in the lower 48. And as you might imagine, that is absolutely market disruptive. And I would say that the board here at Pacific Dataport is 100% okay with that.
I would imagine this project would be a model for other parts of the country, maybe other parts of the world as well. I mean, this is a lot of innovation taking place here, especially with the MicroGEO, isn't it?
Well, if you consider we have about 737,000 residents in Alaska, half of those people live in what you might categorize as urban areas. That leaves about 350,000 people in urban areas. And we know that at least one out of three is considered unserved or underserved. So when you have kind of a very targeted group of people, and you don't have $500 million to spend on a satellite, this MicroGEO option is probably the most economical way to reach those people. It might even be a small country who decides that they're going to do something with broadband or cellular backhaul. It really does open up a lot more possibilities if you are a smaller government or an organization where you want your own satellite, maybe for security reasons. These MicroGEOs are a whole new possibility for an organization to, own their own satellite. And of course, we were the first one to buy an Astronis satellite. So we have a great relationship with these guys, and they were amazing to work with.
Well, I think in 2 or 3 years, my children or your children will do a case study on this and say, well, look at this, and show the incredible value you're bringing to the rural communities. And because there's so many places so remote in so many parts of the world. I can stay on the list, but I think anyone listening to this, they may be looking around saying they live in a rural community that are underserved. And Shawn, I just want to thank you for helping our listeners get a better concept of how to provide broadband services to these unserved and underserved communities. And there are a lot more of them than we realized. I'd like to thank our guest, Shawn Williams, Vice President of Government Affairs and Strategy, Pacific Dataport. Shawn, thanks for your insight today.
I appreciate your time. Thank you for the invite, and I had a good time. Thank you, John.
Thanks for listening to Constellations, the podcast from Kratos. If you like this interview, please subscribe, tell a friend, and give us a review.